Let's take a deep dive into a very common question on those state tests if you're in an algebra course. So if you're taking your state testing, it's very common for them to say, select all ordered pairs that satisfy the function. So I got two different examples for us here. We'll do the work in the middle, and I'll show you how to make sure you get all points on these types of problems, because typically when they say select all ordered pairs or select all answers that apply, there's going to be more than one correct answer in there. So how do we find the multiple answers that may be hidden within our problem? So think about these ordered pairs. The first thing you have to understand is that an ordered pair will always be written as an x and a y coordinate. The first number is the x, the second number is the y. Each of your functions is going to have an x and a y in it. So notice we got x and y in both of our equations here. So we're going to want to replace the first number with x, the second number with y. Makes a little bit more sense when the numbers are different. Here they're the same. Okay, so let's just write out our equation. Y equals 4x plus 3. We're going to do the one on the left side first, and we'll make sure that we put an x in every box that is an accurate answer to this, or an accurate solution to this equation. Okay, so we're going to take -1, which is my x, put it right there. I'm going to take -1 and put it in for y. So I'm going to replace y with -1, replace x with -1, and then we're going to work it out. So 4 times -1 is -4, and -4 plus 3 makes -1. Is that true? Yes, it is. -1 equals -1. This is accurate at the end, so we're going to put an x right there in that box. Now, when you go to replace the information with 2 and 11, you really just need to erase these sections here and here. You can keep the 4 and the 3 inside your equation because we're just changing our numbers. So 4 times 2, 4 times x, 2 is the x, 11 is the y. 4 times 2 is 8, 8 plus 11, or 8 plus 3 is 11. So does 11 equal 11? Yes, it does. We put an x in this box as well. So we're going to erase and replace. Now we're changing it to 4 and 7. 4 is the x, 7 is the y. 4 times 4 is 16. Looks like we're already going to be much larger than 7, so I would not put an x in this box. Change to 7 and 1. 7 would go where 4 goes. 1 would go where the y is. So 4 times 7 plus 3 is supposed to make 1. 4 times 7 plus 3, there's no way that's making a 1, so I would just empty that box, keep that box empty as well. These are your two solutions to this given function. Okay, now if we're going to this problem, the only difference is we're going to have to multiply by a fraction and then add 1. Okay, so multiplying by a fraction can be difficult as long as if you don't know what you're doing, but let me help you along with that right now. Y equals 2/3 x plus 1 is our equation. Now we're using these numbers, so I'm going to be putting a -3 in for x, a -1 in for y. I still have the 2/3 and the plus 1. So when you're multiplying a whole number times a fraction, multiply the whole number times the top number. -3 times 2 is -6. Keep the bottom the same. And that's how you multiply whole numbers times fractions. So let's see what happens here. -6 divided by 3 is -2. -2 plus 1, well, that would be -1. So you're going to get an x. Next, change the -3, change the -1. Now we're using -2 and -1, -2, -1. Wait a second, think about this. Didn't we just multiply this times -3 and get -1? How would we multiply by -2 and get -1? That's not possible. So I can confirm right away, if -3 produces a -1, changing the -3 to a -2 won't produce the same value. So I'm going to leave that box empty, and I don't even really need to work through that problem there. Now, let's try 3 and 3. 3 is y. 3 is x. Let's see what we get. Change the x and y's to 3's. 3 times 2 is 6 over 3 plus 1 equals 3. 6 divided by 3 is 2. 2 plus 1 does equal 3. This checks, so I'm going to put an x in this box here. And then last but not least, I have to check 5 and 6. So put the 5 in for the x, the 6 in for the y. 5 times 2 is 10. 10/3 would be a decimal. And if this makes a decimal, such as 3.3 repeating plus 1, that is not going to be equal to 6. That does not work, so I would leave that blank. So let's take a step back here. It looks like on the first problem, the first two ordered pairs were solutions. On the second problem, the first and the third ordered pair were the solutions. Hopefully this makes sense. Study hard. Prepare yourself for those state tests. You got this. Good luck. You can do it.